Hey everybody, we're back again for another C++ lesson with my son Alex. How's it going, Alex?
Hey guys.
Yeah, we got a professional recording going on
Yeah.
now.
Yeah, I got a bit of an upgrade, so
That's it. That's what it's all
hopefully
about.
hopefully it won't be so grainy, but
Yeah.
we'll see.
Yeah. I love it. I love it. Great. We got another important lesson for you today, as we always say.
As always, yeah.
So let's jump right into it. Great. So today is an extremely important lesson. This is talking about vectors. Have you ever heard of vectors before?
Yeah, I've experimented with vectors
Okay,
a
great.
little bit.
Cool. So this won't be like a completely new thing for you, which is helpful. Great. So for people that are following along, this will probably take a couple times of watching to really kind of get your head around the idea of this. So if you don't get it all the first time around, please, it's natural to do this, and it's going to take you some time to really ingrain this concept to where it's second nature for you. So don't be too harsh on yourself. So for this lesson, we are going to give a high level overview of std vector, which is in the standard library, and we will talk about what a vector is. We will talk about the coding concepts of making a vector, and then we will do a practical walkthrough in Xcode. So what is a vector? So if you were to ask a mathematician what a vector is, they would probably say that it's an object that has a magnitude and direction. So that is what is very commonly referred to as a vector. And you hear about this in like graphics programming and math when you're talking about calculus. But that is not what we're talking about today. Okay, this is a different type of vector. So a vector is, the technical definition of a vector is what you would say is a container of contiguous elements, okay, in C++. So let's break down what that actually means, Alex. So when you think of a container, what do you think of? Just the word
Yeah, so
container.
so just something you put in or
Yeah,
something that can have stuff put in it.
exactly. So it's something that holds something else, right? So like a
Right.
box is like a container, right? And then you have this word contiguous, right? So sometimes in programming we like to use these big words that mean quite simple things. So contiguous, do you know what that means, Alex?
I don't know.
You
I
don't
think
know.
it means something like it consecutive, but I don't actually know.
Okay, nearly there. So contiguous just means the same. So all of the objects. So it's a container that needs to hold something that is the same. Okay.
Okay. Okay.
So yeah. So a container is something that holds something, and contiguous just means that everything that it holds has to be the same. Okay. So like this box of chocolates here. So it's
Hmm.
a container, and it's holding these chocolates, and all the chocolates are the same, or they're of the same type, right?
Right.
So what kind of things can a vector hold? So it can hold simple things like ints. Okay, so you can have a vector of ints, and that would be a collection of integers or floats. But you can also put your own objects in there. So you could also, if you made a car class or a car struct, you could put cars in there. If you wanted to have 100 cars in your game, then a natural place to put that would be in a vector. Or an enemy, if you had a bunch of enemies that were in a game, maybe you'd have these enemies held in a vector. Or students, if you had like students, you were doing something with their grades, maybe these students would be their names, or their grades might be held in a vector. Okay. So let's just talk about something simple, a vector of ints. Okay, so this is the structure of kind of what a vector looks like. So a vector is a very abstract concept, but it's actually kind of a simple thing. And this is what a vector of ints might look like. So you have the first element, which would be the number 5, the second element, which would be number 2, third element, which would be 3, and the fourth element, which would be 6.2. So what's wrong? Do you see anything wrong with this, Alex?
Yeah, 6.2 is not an integer.
Yeah, exactly. So this would not work. This would not compile because 6.2 is not an int. So that would not work. Say, okay, if you had a vector of floats, this would all work because 5 could be interpreted as a float. Same thing for 2 or 3. But because we're talking about an int type, the number 6.2 would not work, and your compiler would complain that that's not the same. That's not the right type for this type of container. Okay, you can only put ints into this particular box. Now, we need some way that we are able to refer, or that we need to be able to get the value back from this vector. So once again, it's a container, right? So it's all these numbers that we've had thrown into a box, and we need some way to say, okay, well, what's the first element of this vector? So we have this thing that's called an index. So when we talk about an index, the index means what element in this vector are we trying to look at. So the interesting thing about most, I would say probably 98% of computing languages is that there's this funny thing that happens where we start counting with 0 rather than counting with 1. Okay, so in your when you're looking into this vector and somebody talks about what's the first index in this vector, they're actually talking about the 0th element. Okay, the number element 0 when they say the first element. Okay, so and then it goes up from there. So you got index 1, which would refer to the value 2, and then index 3, or index 2, which would refer to the value 3. Okay, so let's ask some trick questions here. So what's the first element, Alex?
5.
5, right? So once again, remember when people are talking about the first element, what they're referring to is element 0. Okay, there are a few programming languages like MATLAB that are different. They start with index 1, and that throws everybody off again. But most languages, JavaScript, Python, most common programming languages start with index 0. Okay, so let's ask another trick question here. What is the size of this vector? Okay, do you have any, what do you think about that, Alex?
Well, my first answer would be 3. It would have 3 elements. But since it's not technically a valid vector, I would say it doesn't work in the first place.
Okay, so let's pretend 6.2 isn't there, right? So if it's just 5, 2, and 3, what would your final answer be there?
3.
3. Yeah, exactly. So once again, this throws people off because they see the index 2 is the last index, but the number of elements in the vector is actually 3 elements, 5, 2, and 3. Okay, but since we're starting the counting from 0, that's what throws people off when they see the 0, 1, and the 2. Okay. Any questions about that so far?
No, sounds reasonable.
Great. So now we're going to talk about the actual coding for how to code a vector, basically. So one way that we could code this is we have the std vector. So we declare the vector, and then we have these angle brackets in which we put the actual type that this vector is going to be. So once again, we can't put bools in it, we can't put floats in it, we can't put cars in it. We can only put ints in this vector. Now, and then the myvec part is the actual name of the vector. So you have to give the vector the name because you need some way that you're able to refer to it at a later point. And what we've done is we've initialized it with elements 5, 2, and 3. Okay, so it's just a vector declaration, and we've initialized it with 3 elements, 5, 2, and 3. Okay, another way that you can initialize a vector is you don't have to put any elements in it. So here we have, once again, std vector of type int, and it's called myvec, but we haven't given it any elements. And what's nice about a vector is that we can actually put elements in it and take elements out and take things off the front of them, put things at the end of them anytime that we would like. Okay, so it doesn't need to know the size at compile time. Okay, so this is an initialized vector with no elements. Any questions about that, Alex?
Yeah, so is it respective? So it's 5, 2, 3 in the first, second, and third order respectively?
That's right. Yeah. So this is declared in the order that that you want those elements to be.
Sure. Okay.
Okay. So now we're going to take our vector. We're going to initialize it with these three values, 5, 2, and 3. Now we can use, I'm going to show you 2 or 3 things that are actually like very commonly used. I mean, there are a load of different things that you can do with the vector to actually add elements, take elements out, so on and so forth. So one of the first things that you need to know when you're trying to do anything to all the elements in a vector is you need to know the size of the vector. And you can get the size of the vector with myvec.size or vector.size. Okay, so that will give you the size of the vector. Okay, so what would be the size of myvec in this situation, Alex?
3.
Yeah, exactly. And what would the final element index be?
2.
2, exactly. Great, you're learning quickly. Okay, so another one is myvec.pushback. And then in parentheses, we have the value 22. And this means add another element to the end of myvec with the value 22. So now in this particular situation, we would have 5, 2, 3, 22. Okay, so that's how you would add another element to your vector at the end. Okay, any questions about that, Alex?
So what if you initialized a vector without elements and then you tried to determine the size?
Well, it would return a 0 then at that point.
Okay.
Yeah. Okay. Another thing that we commonly want to do in a vector is we want to find out what is the value of a vector at a certain element. So in this case, we want to find out what is the value of the vector at index 2. Okay, which would be what, Alex, in this case?
3.
3, exactly. So that's asking what is the value of the third element of my vec, which is 3. Okay. Great. So now we'll take our vector again. And once again, it's an initialized vector with the elements 5, 2, and 3. And a very common thing that we would need to do in coding is that we may need to change, or we may need to do something to those elements, or we may just need to see what those elements are at a particular point. And so this is a very common thing that you're going to do in coding, and is something that you're going to do hundreds and thousands of times if you continue your coding career, which is going to be a for loop, where you need to loop through the elements in the vector. And in this case, what we're doing is we are just consoling out what the element in the vector is. As we can see, what happens is that if we go through the first time that the for loop runs through, I is going to be 0. We put, when we go into the braces there, we see myvec I at that point is going to be 0, and it's going to console out the 0th element. Then that's going to finish. It's going to go back around. It's going to do 1. I is going to turn to 1. It's going to put myvec 1. Then it's going to console out what, Alex? What would it console out there? If it was
for 2?
Yeah, so exactly, it would console out 2 at that point. And then what happens is that it's going to loop around again. Then I is going to be 2. 2 is less than, did I make a mistake here? I did make a mistake. That's supposed to be my vec.size, not my vec.size minus 1. Because once we get to, we're not going to get a chance to get to the second element, right? Because my vec.size minus 1 would give you what, Alex, in this situation?
2.
2, right? So when I is 1, and then that finishes, then I is going to turn to 2. And what we would probably want is some way to cancel out the last element, which is going to be 3. But we see that we're going to run into this problem with the for loop where 2 is not less than my vec.size minus 1, which is going to be what, Alex?
Sorry, say that one more time.
So what would my vec.size minus 1 be?
2. Well, after the first loop, yeah.
Just this part right here. So I'm just looking at this. Sorry, this part right here. My vec.size. So what's my vec.size?
3.
3, and then minus 1 would be 2,
yeah.
Right? Which means, and then you would have this condition of, is 2 less than 2? Which it is not, which means that it would break out of that for loop at that point.
Oh, okay, that makes sense. Yeah.
Okay, so this is a mistake, and then what you really want is this, right? Because what would happen is my vec.size is 3, and then you have 2. The final time in that loop, I would be 2. 2 is less than 3, and then it would go into that loop.
Right. Okay.
So let me make sure. Let me make sure I got that right. I'm feeling. Yep. So we're good. There now. Okay. So okay. So that is it, and then we're going to go through a walkthrough right now just to make sure that we're actually right about that. I'm starting to kind of doubt myself now. This is like C++ 101. See, when you do so many things, you start doubting yourself, right?
Yeah,
So the first thing that you need to do is you actually need to include another header. So you need to include vector. Okay, so this is another library from the standard template, the standard library, the standard C++ library. Okay, so let me show you what happens if you do not do that. So once again, we're just going to do exactly what we did in this coding walkthrough. So we got std vector of type int, and this is just going to be called myvec. And then we will have 5, 2, and 3 as our elements. And if we try to compile, we see we get this build failed, and we get some sort of weird error, implicit instantiation of undefined template, std vector, So that's a little bit of an ambiguous error. I think it used to say unknown type or vector is not a part of the standard template library or something like that. So that's a little bit of a ambiguous error that doesn't really tell you what is happening with it, where it's basically saying we don't know what vector is. But we see that we include vector, and we immediately get a build succeeded. So now we are fine. Okay, and then now let's do our for loop. So once again, you're going to write thousands of these. myvec is less than, or I is less than myvec dot size I plus plus, then std cout myvec, and then the I element. Okay, and we will compile that. We see that we get build succeeded, and we get 5, 2, and 3. Okay, so let's experiment with this for a minute, right? So there are a couple things I'm not quite sure what is going to happen. So let's try this, right? So let's see if we can index outside of the range of our vector and see if it actually compiles. So we see here that we have a situation where we've actually tried to access an element that is outside of our vector range, right? It gave us a 0. What's interesting is that I thought it would give us some type of random value. So here we go. So you saw the first time that I did that it gave me the value 0, right?
That's weird.
Yeah. So, but the next time that I did it, it starts giving us these weird numbers, right? So let me just make these bigger for people that may be watching from their iPad. So you see that we get these huge numbers, right? So what do you think is happening there, Alex? Any ideas?
Just a random guess. I'm assuming it has something to do with the address. I have no idea.
Very good. Yes, that's a great insight right there. So the thing about a vector is that these are actually where what happens is when you set up a vector, it actually sets up the size of how much memory it takes to hold an int, and it actually just puts these things right next to each other, right?
Sure.
So it literally takes I think it's 4 bytes, I think, is for an int, and it depends on your operating system. But basically what it'll do is it'll reserve that amount of space to hold the number 5, and then it'll do the same thing to 2 and 3. And literally what it does is it hops addresses as it's going into the next index. Now, when you're going outside the range of what you've already reserved for the vector, then you run into this uninitialized memory, right? And there's a random value in there, and that's what's happening here, is that you're running into memory where we haven't actually given it a value, and it's outside the range, and that in what's held in those memory addresses is actually just these really wild values. Okay, so that's what's happening there. So that's a very good insight right there. Okay, any questions about that?
I mean, it just seems weird that it would do that. But actually, my question was related to dot size. So I assume you can put something in those parentheses, or is that too far ahead?
No, you can't put anything into the parentheses into this here. You can't put anything in the center here. This just means that this is a method or a function, right? And
Sure.
this will just return the size of your vector, right? So let me just demonstrate what that means for you, right? So let's do a class really quick. We will just call this class vec, and then I will just do this, and then what you would have here is you would have something like this, int size, and then return vec.size.
Right.
Okay. Something like that. Okay. And then you'd have something that would be in your private section that would be int size. Or it would just say return size, actually. Sorry. Like this.
That makes sense. It's just like a function.
Yeah. So let me make this right. So let's call this get size, and then this will have an int that would be size, and then this would just return what the size of it is.
I see.
So that's what that's about. Okay, so
right.
You can make functions that don't have arguments with them, like int main. See, int main actually can have arguments in here, but the simple way is not to have them in there. So the parentheses just means that it's referring to a function. Okay. So
I'm sure
yeah.
there's going to be countless examples of that.
Oh yeah, loads. Yeah. So any other questions here about this uninitialized memory?
No, no.
Yeah, but notice that the danger here is that it's gone outside those bounds, and there's nothing. There are no compiler warnings. There's nothing that has warned you that you've gone outside of your bounds. So imagine if you were doing something important and that you were expecting the range of this int to be somewhere between, let's say, 0 and 10, right?
Sure.
And
Yeah.
now you're getting these ranges, in the billions or tens of billions, the really big, really large ranges. So that would probably cause whatever you're trying to do to really go yeah. But it's a very common problem. It's a very common problem that happens in programming, where what happens is that you have some sort of range, that you have some sort of number of elements, and something has happened where you're trying to access something that where you're going into elements that you thought were initialized, but they were not. Okay, so that's the danger there. So you can also so that's a good example. So you can see that there's a danger in there of going outside the bounds of your vector. Okay, another thing that you can do. So you can do loads of things in here, right? So you could do, you can actually change what's in here, right? So you could say, my vec I equals, 10, right? So and then what we'll do is we'll do another for loop where we'll just console out. We'll just console out what the values are. J is less than my vec dot size, J plus plus, and then the C out my vec J and L. Okay. So what it'll do is it'll make all of these elements 10, and then hopefully we'll console them out, and we see that all the elements are now 10, right?
Okay.
Yeah. So there are things that you could do like this. So you could say int my int, and then we're going to use, we'll say this 5, and then my vec I equals my int plus plus. What do you think will happen here? What three numbers do you think we'll get in there?
6, 7, and 8.
6, 7, and 8. So let's see.
5, 6, 7. Okay.
Yeah, nearly. Yeah, that's just an order of operations thing right there. So what would happen is that this is a bit confusing. So you can write my int plus plus, and this is one of the quirks of C++. Or you could just say plus plus my int. Now, if I do plus plus my int, then we should get 6, 7, and 8, right?
Oh,
which is interesting, right? So this brings up a great point about the plus plus aspect of things, which is that you can do I forget what the technical name for it is. It's like pre-increment versus post-increment. So what happened here was that this line 19 executed the first time around when this is 5, 6, 7. Line 19 executed, and then it did the plus plus to my int, right?
okay.
Yeah. And
So
then
it stored it first, and then it looped back, and then added.
Exactly. So these are the little quirks that you can run into. You can also do a similar thing here where the I plus plus can be plus plus I, and depending on the situation, that'll give you different results as well. Okay, but except the only thing there is that if you do plus plus I, then you might intuitively think, oh, I is going to be 1 the first time around, but that's not the case. Okay, so I could probably work out. If I had time, I would work out an elaborate example of how plus plus I would be different than I plus plus, but I'm not going to do that because I might just confuse you. So, and confuse myself. But yeah, but that's something very interesting that you got to pay attention to, which is whether you're going to do post increment or pre increment. Okay. So what else can we do here? So
Actually, wait. So just to clarify,
yep.
it seems like you're kind of suggesting here that in theory, a vector can be of infinite size.
How big can a vector be? Yeah, I don't know if there's a max size to vector. I mean, I guess it could be as big as your memory is. I don't.
Right, yeah.
Yeah, because what you're putting into the vector is really going to determine how big the vector is going to be, right? If you have some sort of massive class here, stood vector, high def photo, like those vectors would be humongous, right? So it's really the type of vector that's going to be inside that's going to determine how big the vector is going to be. Yeah?
Yeah, that makes sense.
Yeah. So another thing that you can do, so I'm not, let's see if I could do this right. So we could do, you can actually write functions that take vectors as well. So we could do something like, and you can actually have like a return type of vector as well. So let's do something simple, right? So we'll do our classic add one example, right? Where we do stood, where it'll take a stood vector of int, and we'll just call this vec.
Sure.
And then for int I equals 0, I is less than vec, I plus plus, and then we would do vec I plus, you could do vec I plus plus, right? And that'll just it'll add 1 to, each element of this size. So we need vec.size. Okay, so now we're gonna try to tie in some of these things that we were talking about before. So one thing that we'll try to tie in is the reference versus passing in by value, right? So so let's create a vector. So we got stood vector of type int, and then we will just call this my vec, and then we will do add one, and in here you would put my vec, and that works because my vec is a vector of type int, and this function expects to take a vector of type int, right? Now if I do this, what do you think will happen?
Well, it'll probably not compile, or it'll have really weird behavior.
Exactly. So no matching function for call to add one. Okay, so that just means, hey, you're trying to pass in a float vector, and we need an int vector.
Right.
Okay.
So I'm actually curious what's going to happen here, because the vector. Okay, so the vector is going to be 0. So it's going to be 0, 1, 2. Oh no, I'm confused.
Okay, so let's have a think for a second. What do you think will happen here?
I don't think anything will happen because the vec size is 0, so nothing will actually. It'll be 0 is less than 0.
Exactly. So nothing will actually happen here because we haven't put any elements into our vector, right?
Yeah.
So I hope this is right. So yeah, so nothing actually happened. Okay. So now we can use a function to actually put some numbers into this vector. Do you remember what the function call is to add another element to the vector?
Yeah, so I think it's myvec dot push underscore back,
That's it.
and then the value.
Yep. Okay, so pick a value.
10.
10. Okay. Creative. Okay. Then let's do myvec dot push back. Let's do another one.
15.
15. Okay. And then myvec dot push back, and then one more.
20.
20. Okay, great. I like that. Even increments. Okay. So now what are we going to end up with?
All right, so it's going to put, so the vec size is 3. So this means it'll loop 3 times. No. Yeah, it'll loop 3 times. I think it'll be, since it's a post increment, maybe I was thinking about this too hard. I think it's going to be 11, 16, and 21.
Okay, so let's have a look. Yes,
Yeah, okay.
Correct. Yeah, so there you go. Yeah, nice. Yeah, so this is an interesting one, right? So what if we did this, right? So this is something that may confuse you. Because what if we do this? What if I take this for loop, put this below here? Now what we're going to do is we're just going to console out what we have. Okay. Back. Any thoughts on what's going to happen here?
So, ooh, yeah, that one needs to change. It's going to do the same thing. I assume it's going to be, well, hang on. I think it's, I'm not sure. It might stay the same because you're not actually passing by reference.
Okay. And what's that mean, passing by reference? What's the difference there?
So when you have the function add one, you're not literally changing myvec. So myvec is technically the same. So when you put the console out in the function, it's taking that altered version of myvec and putting it out, which would be 11, 16, and 21. But since now you have that console out below the function is actually never putting out that altered version of myvec. So it's just going to do the same thing, but with the legitimate version, I guess, if you want to call it that, of myvec.
Exactly. Yeah. So like you were saying, myvec is referring to a collection of space. It's a space in memory, right? And when you're passing myvec into vec, we see that this is passing by value. And what will we need to pass by reference here, Alex?
Which an ampersand?
An ampersand. Where at? Any ideas?
I think it's on vec.
Okay. So yeah. So you could do it. You could do it one of two ways. So sometimes you'll see it like this, and I like to do it like this. Okay. But you can see it both ways. Both ways are correct. Okay.
Okay. Yeah.
I've always thought like the referent. Yeah, there are arguments for both, and you have very impassioned C++ developers who will tell you why it needs to be one way or the other. Okay.
Does it actually make any difference at all?
No, it does not. No.
Oh, okay.
So like you were saying, when you don't have the ampersand on there, what happens is that this is passing by copy, right?
Right.
Or passing by value, rather. Sorry. Which means that in here, you have this kind of secret step that happens that you can't see, which is create a local copy of vec or whatever you pass into it, right? And then what's going to happen here is then it's going to say, because it's going to create a local copy inside add one, which means that when this is actually all finished, it's going to destroy local copy. So it won't exist anymore. Right?
Right. Yeah.
So it means that you're actually inadvertently creating a copy of my vec. Good thing this is an int and not high definition photos or something else, right?
Yeah. Yeah.
Now, when you add the ampersand, like you were saying, you're passing by reference, which means that you're actually saying I am referring to the exact object that I'm putting into this space, into my parameters or arguments, right? Which means that my vec is going to be altered. So let's do that pass by value really quick. And we see that, like we expected, it does the add 1 to my vec, but then afterwards we end up with 10, 15, and 20, which is the same. It hasn't changed it, right? If I just add this ampersand, then now we have altered my vec, okay, itself. Okay, any questions about that?
So this is kind of wacky, but can you make a vector of vectors?
Yes, you can. Yeah, so this is something that I wasn't going to bring up because it would confuse people, and it took me forever to actually wrap my head around this concept. But yes, you can have a vector of vectors, right? So let me see here. So the way that this would look, okay, so this is kind of the next the next level for people if you want to follow along. But this is where your mind starts going into a real strange place. So you got stood vector of a vector of vectors. Like that. Okay. So then what happens is that, let me see if I can draw this in like ASCII art or something.
So how I would think of this, we can think of it as like books. So let's say the first vector, my vec, is like a room, right? Mm-hmm. Then in these rooms, you have another vector, which is a container of boxes.
Exactly. And yeah.
So if you push back something into my vec, you're creating another room. Whereas if you push back into the vector in the vector, then you'd be making a box in the room.
That's right. Yeah. So when you actually push back into my vec, you actually have to push back another. You have to actually push back a stood vector of ints. And what's really crazy, I don't know if you can actually do this. So let me see. I'm pretty sure that you can't actually do this. But let me see. Let me see if it does this. Oh, maybe. Oh, it does. It does do it. Right? So what you have to do is you have to push back. You have to push a vector in there, right? You can't just say 0, right? Because it's not a vector of ints, it's a vector of vectors.
So that means that if you tried to see out my vec in position 0, what would it actually push out?
You can't just see out my vec 0. I don't think you can anyway. I don't. Yeah. So see, that doesn't work, right? What you can do, because this is a 2D vector, is you can do this, right? So you have to go into the room, like you were saying,
right,
and then you have to go to the quote-unquote box that's inside of the room. So
in this case, the first box.
Yeah, exactly. So please work. 5. Yeah. So there you go. Or like you have this that will do 2. All right. And then we could do something like this, make it even. So we'll just copy this for just, and then 45. So, yeah, so now I can do, now this has, two elements in the first dimension. So these are called dimensions now, right? So this is something I wasn't meaning to get into today, but these are called dimensions. So you would be saying, okay, now we're talking about the first dimension, and now we're talking about the second dimension of the vector.
So with C++, I can break the dimensions.
Yeah, yeah, exactly. And now another thing, while we're at it, is to show you how you actually can go through here, and you can actually console out all of these elements. So you have to use what's called a nested for loop to do this. So you would say something like for int I equals 0, I is less than myvec dot size I plus plus, and then in here you have to do for int j equals 0, j is less than myvec dot size j plus plus. And then, oops, you got to remember to put the parentheses in here. And then now you would do, so let me just put this in here. This. So this is a very common type of, maybe I shouldn't say this because it might confuse people, but this is a very common thing. Like if you're going through like pixels in a photo, and you were trying to change each one of the pixels. So the pixels, you have like pixels across going from left to right, but you also have pixels that are going up and down, right, on the y-axis. Okay. And if you were trying to go through each one of those and change the color of each one of those, you would use a pattern like this, nested for loop. So we can see here that we have that we've consoled out our elements successfully, right? So, yeah.
So I remember, man, this was probably last year. I was messing around with vectors a little bit for a program, a very complex geometric program. And one of the things, I don't remember how I solved it, but one of the issues that I ran into was that the user needs to input values for whatever geometric thing I was talking about into the vector, but then the vector was an undefined size because let's say it would be like, okay, let's say we need how many sides the shape has, right? So I won't know until the user puts it in that the shape has 5 sides, 6 sides, 100 sides. So the vector up until that point is an undefined size, and I don't think you can do that in C++.
Yeah. So what you'd want to do at that point is you'd want to be able to create a vector once the person has decided the size, right? So the workflow would be, how many sides do you want? The user chooses the number of sides, and then you and then you get the result, and then you create a vector that has that amount of elements in it, right?
Actually, that'd be, yeah. So then if I was, let's say I had a program which took a shape of X amount of sides, and then each side was Y length. So I'd create a vector. I'd create a vector of the size. So the sides would be the length or the index value of the vector, and then for each respective side, the size would be in that position. That's kind of confusing, but.
So I'm not sure if I understand your problem space correctly, but sounds like maybe a 2D vector situation. So
No, well, maybe because let's say the amount of sides is I, and then for each let's say there's 10 sides, right? So vector would have an index of 10. And then for each, like, let's say the first side was 5 inches. So in vector position 0, the value would be 5.
Yeah.
So then if you wanted to recall, what the fifth side or what the length of the fifth side was, then you would print out a vec in position 4.
Yeah. So that. So you're just looking to hold the length of the side in the vector?
Right. Yes.
Yeah, so that would be a 1D
Right.
problem. Yeah.
Yeah.
So, yeah. Interesting stuff. Any other questions? Any other questions here on this?
Is there anything you absolutely cannot put into vector? Well, you said bool. You said I'm trying to remember. You said bools. What else would be?
You can put, as far as I know, you can put anything in there. I can't think of anything that you could not put in there. Yeah. Yeah. It's there's nothing in there that I can think of. I mean, the last thing that I'll tell you that'll really maybe really kind of blow your mind is that a vector is actually the indexes in a vector are actually pointers. Right?
Okay. Okay.
Does that make sense?
Yeah. So it's like if I how do I explain that? So it's like pointing to this specific address where the value would be 5. Is that right?
Yeah, exactly. So you have a memory address, right, where that 5 is being held. So let's take things back to a simple one, right? Very quickly. So we got std vector, and we'll make these type ints again, and then we will say, let's just put one number in there, right? 5. So we have one index in there. So what happens if I say my vec 0 is that is referring to the value 5, right? If we checked what that value is, right, then that's referring to the value 5. Now, I could do this, right? Because this is actually referring to a very specific place in memory, which is going to be right next, quote unquote, right next to the 5, right? It's going to be, but the only problem is that we haven't initialized it. We haven't initialized it to anything.
Right.
Right. So it is pointing to a place in memory, right? And that place is uninitialized. So that's why this is a vector is actually really a collection of pointers. That's what a vector is. So that may confuse you a little bit, but yeah, that's what it is.
So when you actually put out or console out that undefined space in memory, does that literal space in memory change because it's random, or?
Well, let's have a look, right? So let's std cout my vec 1. Let's see what happens. I think there's something that I wasn't aware of that actually takes the index right past the last element, and it actually puts it to 0. Because if I do this, now we have a random value. That's interesting. I wasn't aware. Maybe that's some sort of safety thing that has been done just to for the to keep from like if you have like one off, if you're one off in your vector count, that maybe that last place, that index past the last element is just initialized to 0. Interesting.
It could have something to do with how C++ works under the hood, because obviously when you push back something, it's going into the adjacent spot in memory. So maybe C++ is thinking, okay, let's just set this to 0 because this is going to be where the next pushback is going to be.
Yeah. See, now what? Now watch what happens here. So we have this, 268835562. Now if I compile this again, it's 0. Isn't that interesting?
What the?
And then see, it's just a different value every time. See that?
Yeah, I do. Yeah. Why is it flip-flopping though?
That is a great question that I do not know the answer to. Yeah, I don't know. I wonder if it would do that. This is crazy because this video is taking forever. But I'm curious to see if it. No, that always just.
That's always 0.
Yeah. I wonder if it does it if I do it way past where the limit is. Or if it. No.
No, it doesn't. Okay.
Bizarre. That's bizarre. Yes. Yeah. C++ definitely has a life of its own. Yeah. Cool. Yeah. So it seems like we made some progress there. Yeah. What did you think of that one, Alex?
Definitely my favorite lesson.
Yeah. Yeah. You enjoyed that?
Vectors and vectors. Yeah.
Yeah. It gets so much more interesting once you're able to get past the very initial stages of like ints, bools.
Yeah.
What is a function? What is a for loop? Yeah. Past that stage, once you start getting into using classes and vectors and creating larger abstractions, now it starts to get much more interesting, and you can actually do quite a bit. You can actually do quite a bit just using the knowledge that you have so far. Like you could create a game. You could create a game where people console in things and there are certain actions. Like you could completely do that just using the knowledge that you have so far.
Well, I'll be experimenting.
Yeah, I'm looking forward to your experiments.
Yeah.
Cool. Well, this is where we're going to end it for now, and I hope that was helpful for you. Please, any C++ gurus who happen to be watching this, so we have some esteemed alumni who actually watch these videos, and I hope that they're not too harsh on my C++. But any corrections or anything that's incorrect, please feel free to correct us and let us know how we can be better C++ developers. But for now, we will let you go, and happy coding, and see you next time.
All right. See you later.